Hello my dear students, welcome you again in the video lecture of operating system subject. Up till now we have covered 3 units and out of the syllabus 45% of the syllabus is completed. In last video lecture we have studied a different process control commands. You can run these commands on the online terminal. PS command easily run, but kill, exit may have some problems on the online platform. So my suggestion to my all dear students, if you have Ubuntu installed on your machine, you can easily practice that commands. Okay, otherwise theoretically read the concept about that commands, understand the syntax and option of that commands. Okay, that commands has a specific option. There is no any confusion or no any difficulty to understand that commands and their options. Okay, so in this video lecture we are going to start unit number 4. So unit number 4 is very important unit in your syllabus and its title is CPU scheduling and algorithm. It has a minimum weightage of 14 marks plus it may have 6 marks extra, so it will give you 20 marks in your MSBT question paper. In this video lecture we are going to start 4.1 or we are going to discuss a 4.1. In that we can study the different types of scheduling. Okay, so after watching this video student can easily understand what is the CPU scheduling and objective of CPU scheduling. Second outcome of this video lecture is student can explain CPU and IO burst cycle of process. Then third, student can easily explain different types of scheduling, basic types, that is a preemptive and non-preemptive scheduling. And last, very important, student can easily enlist and explain scheduling criteria. Okay, so my dear students, we already studied in unit number 3 a process is a part of the program which is in the execution. So that process may be a CPU bound or IO bound. CPU bound means a process is completely executed by the CPU, and IO bound means CPU that process is executed by IO devices, or some part of the process is executed by CPU and some part is executed by IO devices. That shifting from CPU to IO is called as a context switching. We already know that. Okay, suppose P1 is a process and some part, initial part is a CPU bound, and after specific period of the time P1 requires IO. Okay, so P1 is in the ready queue, and when CPU is free, then dispatcher will dispatch P1 to the CPU for the execution. That part of the program which is related to CPU is executed, and then for the IO operation the P1 is taken out from the running state and it put into the waiting, because IO devices are slow in the speed or may IO device busy in the execution of another process. Okay, so P1 is shifted from the CPU to the IO. Okay, when P1 is executed by the IO, the CPU remains idle. Okay, CPU does not have any process for the execution. CPU remains idle until P1 get back, and CPU will execute P1 completely and P1 will be terminated. Okay, when P1 is execution in the IO device, CPU is idle. That is a condition, okay, where we required a scheduling. Okay, before understanding scheduling we must understand what is a CPU and IO burst. Okay, so it is a very easy concept. Okay, CPU burst cycle means the time period taken by the process to execute the part of the process by the CPU is known as CPU burst. Okay, in simple language, if P1 is a process, the time period of process P1, which is executed by the CPU, is known as CPU burst. Okay, then IO burst means a time period of process which is executed by IO device is known as IO burst. Suppose P1 is CPU as well as IO related operation, then time period which is executed by CPU is called as CPU burst, and time period or time slot that is executed by the IO is called as a IO burst. It is a very easy. Using this diagram, we can clear the concept of CPU burst and IO burst. Initially, your process is in the CPU burst, then it requires IO device, then that CPU execution is stopped, then start IO burst. When IO operations is over, then it shifted to CPU burst. That process will be executed by the CPU. After the CPU completion, it transferred to IO. So that is a time consumption by the process, by the CPU and by the IO devices is known as a CPU burst cycle and IO burst cycle. Okay, so it is very easy definition and you can explain with this diagram. Okay, so these are the basic concept we require for the scheduling. Okay, so all programs or all the processes are either CPU bound or IO bound, or they are mixed CPU plus IO bound. Okay, when a single process is shifted from CPU to IO device, the CPU remains idle. Okay, so that is a problem when we are shifting one process from CPU burst to IO burst. Okay, when CPU is idle, CPU can easily execute the next process which is in the ready queue. To pick up that process while CPU is idle is known as scheduling. Using the scheduling, efficiency of CPU, fast execution and utilization of CPU power is enhanced, so that we required a CPU scheduling. So basic question, what is a CPU scheduling? So definition of CPU scheduling is like this. CPU scheduling is a process which allows one process to use a CPU while the execution of another process in hold. In hold means due to its requirement of IO device is known as CPU scheduling. So it is in very simple language, CPU scheduling is a process which shift one process from ready queue to the running state or CPU allocation while another process is in the execution, but it is in the waiting for the IO devices. So we can explain this with example. Means P1 is in the execution. Some part of the P1 is executed by the CPU, then it requires IO devices. So P1 is in the waiting state, okay, for the IO device. Meanwhile, we can take a P2 process which is in the ready queue and we can allocate a CPU. So that is called as a CPU scheduling. Due to that, the efficiency, fast execution and performance of overall machine get increased. Okay, the CPU idle condition is very dangerous to the CPU or overall performance. When CPU is idle means CPU does not doing anything. So that is a wastage of processing power of CPU. Okay, to avoid this we must have a scheduling. Okay, so process which is in the ready queue must be taken for the execution when CPU is idle. Okay, to selecting the appropriate process from the ready queue while CPU is idle is known as short-term scheduler, or it is known as CPU scheduler. In CPU scheduler or in short-term scheduler, when CPU is idle or current process is in the waiting state, it will select the next process which is in the ready queue. So scheduler will select the appropriate process from the ready queue and it allocates a CPU for the execution. So that process is known as CPU scheduling. Due to the CPU scheduling, CPU utilization is increased, process performance is increased, overall execution speed get increased, okay, and idle time of CPU will be decreased. So these are the main objectives of CPU scheduling. In CPU scheduling, two very important concepts are there which are required, and multiple times MSBT question paper these questions are asked. So what is a dispatcher, okay, and what is a dispatcher latency? My dear students, we have already studied unit number 3, and in that process state diagram is very important because a dispatcher is already introduced in unit number 3. So dispatcher is a module, okay, so dispatcher is a module which controls the CPU to process a selected process or selected process which is in the ready queue by the short-term scheduler. Okay, so dispatcher is a module, means it is a set of program which controls which process will be allocated a CPU, okay, which is selected by a short-term scheduler. Okay, so my dear student, in the process state diagram, a dispatcher will pick up the process from the ready queue and put it into the running state. Okay, so that module is known as a dispatcher. Okay, so basic functions or basic utilization of dispatcher is in context switching. Yes, when we are switching the process P1 to P2, so context switching dispatcher is used. Also, dispatcher is used in the switching of user programs or from the kernel mode to user mode or in the user programs. So we can shift our programs if you have opened multiple programs at a time. Suppose you have opened video player, audio player, word processor. So when you are shifting the program one after another, so that is some processes are in the waiting, some processes are in the background, and some processes are in the foreground, that can be carried out using the dispatcher. Also, dispatcher is used to jumping a proper location in user program to restart the programming or to get a last instruction to be executed. So dispatcher is a module which have a control over allocating a CPU to selected process which is selected by a CPU scheduler or short-term scheduler. So that is basic definition of dispatcher, and its functions are 3. Dispatcher used in the context switching, dispatcher used in the switching to user mode, dispatcher is used to jumping to the proper location. So that is a dispatcher. Next terminology is very important, that is a dispatch latency. So latency is nothing but a time period. Okay, so when latency word comes, it is relevant to your digital technique. Okay, so latency is nothing but is a time slot, it is a gap. Okay, so what is the role of dispatcher? Dispatcher is the overall control to shift one process from running and to start a new process. Means a dispatcher duty is to stop one process and to start another process. So time gap between to stop one process and to start another process, that time period is known as dispatcher latency. To have a good operating system or to good system, a dispatcher latency must be a minimum so that your processing speed is high. Using this diagram, we can easily understand a dispatcher latency. So event and response event, these are the two events. So when event occurs, there will be appropriate response. Okay, so interrupt processing. Okay, so there is a first process P1 is in the execution, it is interrupted by P2, then P1 will be stopped and P2 will be start executing. Okay, the time period which required by the dispatcher to stop P1 and to start P2. So that is in nanoseconds there will be some gap to stop one process and to start another. That time slot or time period is called as a dispatcher latency. Okay, so it is a dispatcher latency. It is asked multiple times in your MSQ question paper. What is a dispatcher and what is a dispatcher latency? Okay, so reflection spot. Listen this question carefully. What is the CPU scheduling? Stop this video. Write down your answer in your notebook. After the writing your answer, you can play this video again. So my dear students, CPU scheduling is nothing but it is a process to allow one process to use a CPU while it is executing another, but that process is held due to some I/O operation. So that process of selecting process we select a process from ready queue, while one process which is in the execution is waiting for the I/O devices. That concept is called as a CPU scheduling. So it reduces a CPU idle time, it increases the efficiency, faster execution, and reduces the idle time of the CPU. Okay, so that is called as a CPU scheduling. So it is very important point. Your focus must be on this point, because in which situation a CPU scheduling is required. Okay, the situation under which a CPU scheduling is used. So basically there are 4 conditions where the CPU scheduling is used. Okay, to understand this concept you must clear the process state diagram. I will be repeating that your concept of process state diagram must be clear. Then and then you can easily understand CPU scheduling. So to understand CPU scheduling, your 2 concepts, that is context switching and CPU, that is process state diagram, must be clear. Then and then you can easily understand the concept of CPU scheduling. So there are basically 4 conditions where a CPU scheduling is used. First condition, when your process shift from running to waiting. Okay, so my dear student, if you have gone through the process state diagram, process will shifting from running to waiting when I/O devices or I/O processor is required. Then we are using the CPU scheduling. Second, when process is switched from running to ready. Okay, so running to ready, okay, due to the interrupt. Okay, interrupt means suppose P1 is in the execution, but P2 process comes which having the highest priority, then P1 will be stopped. Okay, so P1 will be suspended from running and it is shifted to ready. Okay, so in that situation also we required a CPU scheduling, because we are stopping P1 and we are allocating CPU to the P2, so we required CPU scheduling. Next, third time, switching the process from waiting to ready. Okay, waiting to ready means what? When P1 is in the waiting queue or waiting queue of I/O devices and I/O will execute the P1 completely, then P1 is shifted to ready queue back for the CPU. Okay, so that is a process state diagram. So third condition is nothing but I/O operations are over. Now process is shifted from waiting to ready queue. In that condition also we required CPU scheduling. And last, very important, when your process is terminated, means now process does not require CPU, does not require I/O devices, then a running process P1 must be terminated. Then and then your CPU becomes idle, or CPU is now ready to take a next process. So in that situation, in termination also we required a scheduling. Okay, so these are the four conditions where we required a CPU scheduling. In that condition number 1 and 4, 1 and 4 means running to waiting and 4 means terminating, is known as non-preemptive. Non-preemptive means what? If a P1 is execution is in the running state, complete execution of P1 is done, then and then next P2 will be allocated to CPU. Means non-preemptive means that process cannot be stopped until it will be fully executed by the CPU. So that is called as a non-preemptive. So 1 and 4 condition are non-preemptive and all other conditions, that is 2 and 3, are preemptive. Preemptive means if P2 arrives and it has the highest privilege, then P1 will be suspended. So P1 requires a CPU, but it is suspended. Suspended means it does not get its full time of the CPU. So that is called as a preempted. Okay, non-preemptive process will completely executed by CPU, and after the completion of that process, another process will be allocated to the CPU. In preemptive, current process is suspended and highly prioritized process will be allocated to the CPU. So that is called as a preempted scheduling. Okay. In this scheduling, we are sharing the data. It requires a kernel mode permission. When CPU scheduling is done, we must have a knowledge about interrupt processing and what type of interrupt will be occurred. So all the things can be managed by the operating system. So these 4 conditions are very important. Non-preemptive and preemptive are the 2 types of scheduling. So we can discuss a non-preemptive scheduling first. So non-preemptive scheduling means criteria, condition number 1 and 4. Condition number 1, running to waiting, and 4 is terminating. Okay, terminating means your process is completely terminated. Now the next process in the ready queue will be allocated to CPU. Okay, so under non-preemptive scheduling, once a CPU has been allocated to process, then process keep the CPU until it will be executed completely, then and then it will be released, or it will be terminated, then it will be released the CPU. Okay, so that switching from running to waiting while IO devices is required, or your process is terminated completely. Once a CPU is allocated, then if it is terminated successfully, then it releases the CPU. Otherwise, if it requires IO device, it will release the CPU. That type of scheduling is known as non-preemptive scheduling. Okay, so it can be released when it requires IO devices or it is completely executing. So that type of scheduling is known as non-preemptive scheduling. Okay, so in middle of the execution, process is not suspended. If it requires IO device or it completely executed, then it will release the CPU. Okay, so that is a basic condition of non-preemptive scheduling. This scheduling is used in Windows 3.1, and Apple Macintosh operating system also uses a non-preemptive scheduling. This is the only method used to certain hardware platforms. Okay, especially this method is designed for timers and hardware bound operating system. So non-preemptive means what? Very simple. Non-preemptive means once a process CPU is allocated to process, it will release in only 2 conditions. If it requires IO devices, means running to waiting, or that process is completely executed and it is terminated, then and then another process which is in the ready queue will allocate a CPU. Okay, so that is called as a non-preemptive. Preemptive, it is completely opposite to non-preemptive. Non-preemptive means 2 conditions. First, waiting to ready and running to ready. Okay, in this condition, once a CPU is allocated to the process, If another high priority process will arise, then it will suspend a current process. It will release a CPU and CPU is allocated to highly prioritized process. So that is called as a preemptive. Current process is suspended. That is called as a preemptive. Okay. So due to the interrupt or resume operation or highly prioritized process, the current process will be preempted and CPU is allocated to a new process is called as a preemptive scheduling. Okay, so it is very easy to understand non-preemptive and preemptive. Last point in our discussion is CPU scheduling criteria. So what are the criteria of CPU scheduling? This question asked multiple times. 200% this question is asked in your MSBT question paper. So what is the CPU scheduling criteria? Okay, what are the criteria? Due to that we required a CPU scheduling. Before writing this answer, you must write down the definition of CPU scheduling. So CPU scheduling is nothing but it is a process to allocate a process from ready queue to the CPU while another process in the execution and waiting for the IO device. So basically 5 criteria for the CPU scheduling. First is CPU utilization, second is throughput, third is turnaround time, fourth is waiting time, fifth is response time. Okay, so these 5 criteria are very important. Its definition and its understanding is very important. CPU utilization is first criteria. Okay, so CPU utilization means to decrease the idle time of CPU. When process is waiting for the IO device, the CPU is idle. That will decrease the performance. To increase the performance of system, CPU must be busy. So utilization of CPU will be increased due to the CPU scheduling. So due to the CPU scheduling, we can select a next process in the ready queue to avoid a CPU idle time. So that is called as a CPU utilization. The next criteria is throughput. The throughput is nothing but number of processes completed by the CPU per unit time. So it is a unit of your performance of CPU. How many number of processes are executed per unit time is known as throughput. To increase the throughput, we required a CPU scheduling. Okay, throughput is nothing but number of processes executed by CPU per unit time. CPU scheduling is required to increase the throughput of your CPU. So it is a throughput. Third criteria, turnaround time. A turnaround time is a time spent by the process to execute a particular process completely. Okay, so amount of the time taken by the process to complete execution is called as a turnaround time. Okay, turnaround time is nothing but addition of time spent by the process in the ready queue plus execution time. So it is called as a turnaround time, or simply a turnaround time is time amount of the time executed particular process. Okay, so it is a time of CPU which execute the process completely. Okay, the waiting time is nothing but the time that process spent in the ready queue. So total time spent by the process in the ready queue is known as waiting time of that process. To decrease the waiting time, we required CPU scheduling. Okay, also to increase the turnaround time, that is response time. After the definition of response time, we can easily understand the turnaround time. Response time, the amount of the time taken from, or amount of the time from when request is submitted and first response is produced is known as response time. Response time is nothing but when your process in the ready queue, it spend some time in the ready queue, that is a waiting time. Okay, Okay, so when that process get first chance to get a CPU, so time required by the process to get a first response by the CPU is known as response time, because response time is minimum. If your process is IO bound, then it will be turned into the waiting and then it will be in the ready. So turnaround time is a addition of response time plus waiting time plus execution time. So that is called as the overall turnaround time. My dear students, it is not easy to understand turnaround time. When we take the example, we can easily understand a turnaround time. Okay, waiting time, the amount of the time spent by the process in the ready queue is called as a waiting. Response time, it is a first response by the process when it is requesting the CPU and CPU will be allocated. So that is called as a response time. Okay, to understand this concept, I will take the general example. Then and then you can easily understand this concept, because a queue. Okay, queue is a very important concept. Suppose I am in the queue of getting a film ticket in the cinema hall or cinema theater. Okay, so I will arrive in the queue. Okay, when I will be arriving in the queue, so how much time I will spend in that queue is called as a waiting time. Okay, when I will come in the queue at the 10 a.m. and at 10:30 I will be the first member in that queue. Okay, so half an hour I will spend in the waiting, so that period is called as a waiting period. Okay, after that we can get the response. Okay, in 10:30 I will get the response in the ticket window. It requires 5 seconds to complete my process or 5 minutes to complete my process. I can get the ticket at 10:35. So 5 minutes is my response time. I will be in the ticket window, but 5 minutes that person who is allocating the ticket will be not listening to me. After the 5 minutes he will listen and how many tickets he asks, and I will give the money. So that time period when I get first response and I will allocate the CPU, that 5 minutes is called as a response time. Okay, and then if that person, in third condition, if I will be in the waiting for half an hour and I will be in front of that ticket distributed person. If that ticket distributed person will assign me 2 tickets and it requires a chain, okay, I will be giving him 5,000 or 1,000 rupees your money, and it will return me 2,000 back. If 2,000 is not available or 200 is now not available, I have given 1,000 rupees, ticket price is 800, so he must return me 2,000 or 200 rupees. 200 rupees chain he has not available, so he went to his accountant to take money. So there will be some waiting in the ticket window, so that waiting also will be added. So total time spent by me to get a ticket in the queue plus response time, and after that I also watch a 3 hours movie and then I will be out from the theater. So half an hour plus 5 plus 3 hours. Okay, so that total time is called as a turnaround time. Okay, so it is like this. Okay, so forget about the general example, concentrate on the technical concept. If does not understand, you can go through the reference book and you can easily understand that concept, or you can watch this video again and again. When we start a next point, I will repeat this definition of throughput, turnaround time, waiting time and response time, because in algorithms we must calculate this turnaround time, waiting time and response time. So these are the 5 basic criteria. Due to that we required a CPU scheduling. CPU utilization, that is CPU must be busy. Throughput, number of processes must be executed per unit time. Turnaround time, a total amount of time that process required for the execution. Waiting time, the total amount of time process spent in the ready queue. Response time, a total amount of time to get a first response from the CPU is known as the response time. So these are the 5 main criteria. And basic objective of CPU scheduling is to maximize a CPU utilization, to maximize a throughput, to minimize a turnaround time, to minimize a waiting time, to minimize a response time. So these are all time span. Okay, so time span to get a next process. So it must be a minimum. Throughput, number of processes executed per unit time must be high, and CPU utilization must be high. So these are the basic objectives, these are the advantages of scheduling, and these are the 5 criteria which are required for the CPU scheduling: CPU utilization, throughput, turnaround time, waiting time and response time. So this is very important point. Your focus must be on the CPU scheduling definition, criteria, conditions and a definition of turnaround time, waiting time and response time. Okay, also we must have a clear definition of preemptive and non-preemptive scheduling and 4 conditions where the CPU scheduling is required. So my dear student, I can easily understand that these are some technical concepts. In first glance you cannot understand this, so you must listen this video multiple times. Okay, you can understand this concept. Okay, you can utilize the reference book, you can have a different videos on this concept, you can have a different resource material available online. So my suggestion is that this is a very important concept. You must revise this concept. You make your own notes of what is a CPU scheduling, what are the objective of CPU scheduling, what are the condition where CPU scheduling is required, what is the IO burst, what is the CPU burst, basic 5 criteria for CPU scheduling, then what is the objective of CPU scheduling. In next video lecture we are going to start a 4.2. Before going to start the 4.2, I will revise the definition of a response time, waiting time, turnaround time. Okay, still then stay at home, stay safe, stay healthy, happy learning.